In this problem, I've asked the students to sketch the shear and moment diagram of a simply supported beam with a uniform distributed load acting on the right side of the span. So as you can see here, the beam is 20 feet long. The uniform distributed load of 1 kip per foot is acting on the right part of the beam, and you have to draw the shear and moment diagrams. Well, before we do that, we need to compute the reactions. So we're going to have a total load on the beam of 10 kips, right, which is 1 kip per foot times 10, acting in the center of these 10 feet. So that gives you a uniform point load here of 10, 15 feet from the left, 5 feet from the right. This reaction, let's say we call it B, we can obtain it by doing sum of moments about this point. And so that ends up being 10 times 15 divided by 20 gives you 7.5. By vertical equilibrium, that's 7.5 minus 10, so then you get 2.5 here at the left support. So 2.5 reaction on the left, 7.5 on the right. So we start looking at this to determine shear diagrams. So we just have a point load here, nothing until we get to the mid-span. So that gives you a constant shear of 2.5. Then after we get to that point, the shear drops by 1 kip per foot. So that's a 1-to-1 slope going down from 2.5 all the way down to 2.5 minus 1 times 10 gives you minus 7.5, and then it comes back up because of this reaction, closes at 0. So that all looks good. The last thing we need to determine is the point where the shear is 0, because that'll match with the point of maximum bending moment. So since we start here at 2.5 and we're going down 1 kip per foot, that tells you that the shear will be 0 at 2.5 feet from the mid-span. Okay? Now to draw the bending moment diagram, we start at the left support. We have a shear of 2.5, which is the slope of this line. We carry that for 10 feet and we get 25. At that point, the slope begins to decrease, right, until it reaches a slope of 0, which is the point of maximum bending moment. And to get the value there, we simply have to add the area of this triangle right here to 25. And that area is 2.5 times 2.5 divided by 2. That gives you 3.13. You add that to 25, you get 28.13. From that point on, the parabola acquires a negative slope, and it goes down with increasing slope until it reaches 0 at the right support. And so that's the shear and moment diagram for this beam.